Good afternoon, sixth period. Today you are just practicing calculating the volume. We're going to be calculating the volume for lots of different problems, and that'll be your job. Just think about the shape you've got, think about the dimensions you have, go ahead and calculate the volume. I would recommend you go to our three-dimensional shapes page right here, and you rip that page out. You're going to be using this on the test. This is your study guide for the test. But if you rip it out now, it'll be really helpful as you jump to later pages. Once you've got that ripped out, go ahead and turn the page and get all the way to page 11. Okay, here on page 11, we've got two different situations, and you should have done these yesterday, so I'm going to use these as example problems. The first one is this. Lonzel needs to store 20 cubic feet of firewood. Could he use the storage rack shown? Well, let's take a look. If Lonzel wants to use the storage rack shown, the first thing we want to recognize is that this is a triangular prism. It's got a triangle base, so it's a triangular prism. Now, I really recommend, as soon as you know the name of the shape or the type of shape it is, you write down what the general volume formula is for it. It will be very helpful to you in the future as you develop this. So the volume of this triangular prism is equal to the base times the height divided by 2. That's the area of the triangle times the length, or how far back, or the depth of that triangle. Okay, I think that's a formula we used. So we just need to know our base, we need to know our height, and we need to know the length. If I take a look at this, my base is 6, my height is 4, and my length is 2. So putting those dimensions in there, we've got 6 times 4 divided by 2 times 2. And we're going to go ahead and solve, or simplify. Can divide by 2 and multiply by 2. Those can cancel. And we're just left with 6 times 4, which is equal to 24 feet cubed. So Lonzel needs to store 20 cubic feet of firewood. And notice that he's got 24 feet cubed of space. So normally Lonzel would be able to fit them in this storage rack. But there's kind of a problem here. Hopefully you notice it. His storage rack is already full. So normally he would, but the storage rack is full. I find that to be really funny in this problem. So that's one thing we want to add. Normally, yes. But his storage rack is full. I just find that to be really funny. All right, now let's go ahead and take a look at the second problem here. Keisha is deciding between two canisters shown. Which canister holds more? What's the volume of the larger canister? Now, looking at both of these canisters, notice that they both are 25 centimeters high. They're both 20 centimeters across. This one has this weird diagonal that is 27 meters long. So which one is larger? Now, one of the things that you hopefully kind of understand from what we talked about yesterday is that volume for prisms and cylinders and things like that are the two-dimensional shapes stacked on top of each other. So this is just a whole bunch of circles of the same size stacked on top of each other. Now over here, we still have a whole bunch of circles. They're all the same size. They're all 20 centimeters wide. They're stacked on top of each other, but they're stacked in just a diagonal way. So it turns out that the area of this cylinder, or quasi-cylinder, and this cylinder are going to be equal because they're both just stacking circles on top of each other. This is just stacking them in a diagonal fashion. And whenever you've got a situation like this for any type of shape, it's called an oblique shape. In this case, this is a cylinder, so we call it an oblique cylinder. And so this is very similar to the way we calculate the area of a parallelogram. We would take kind of this section here And it turns out that that section, if we rotate it, it would perfectly fit here. And so we end up having a cylinder going straight up. It would be the same volume as this one. So if we know the volume of one cylinder, we're going to find the volume of the other cylinder. Let's go ahead and think about the shape. Oh, they're cylinders. C-Y-L-I-N, and I'm going to use a different color real quick. C-Y-L-I-N-D-E-R. So this is a cylinder, and that means the volume of a cylinder is equal to pi times the radius squared times the height. And I know the radius. The radius is not 20 centimeters, it's actually 10 centimeters. And the height is 25 centimeters. So I can go ahead and just plug that in. Pi times 10 squared times 25. Now, of course, I've got units of pi here. I don't want to try to approximate it. I want to try to get the exact value. So I'm just going to keep pi by itself. And then I got 10 squared. That's 100 times 25. So this becomes 2,500 pi. That is the volume of this cylinder. And this is centimeters cubed. All right, so we're able to get the volume of both of those. Again, both of these problems you should have been able to do at the end of yesterday. What are you supposed to do today? Well, you want to start here. Go to example number 3. With example number 3, you want to find the volume of this sandbox or soil box, and you also want to find the volume of each of these. You need to find that volume so that you could find out exactly how many bags of soil will you need to buy to fill that box, okay? So you want to find out two things, the volume of the box and the volume of the soil. And then you need to go a little bit further, think, okay, now that I know those two volumes, how am I going to do it? One quick tip is that the volume of the soil we're going to consider to be a rectangular prism. And that's because, you know, soil bags don't exactly look like rectangular prisms, but we're going to consider it to be a rectangular prism. Okay, think about the box, find the volume of each of those, and then think what do you need to go further to actually answer the question to find out how many bags she should buy. All right, come down here, go ahead and find the volume of this fish tank, and then convert that volume to gallons, find out how many gallons are needed, and then knowing those gallons, find out how many fish are needed. Neon tetras are kind of violent. They will attack and if they do not have enough space, so you don't want to get too much space there. Benito has a real problem, way too many aquariums in his house, so you're going to go ahead and try it out on this one too. All right, then come on over to the next page, and I want you to be thinking about this. You got a cube and a pyramid. Think about how many pyramids you think will be able to fit inside this cube. We'll be talking about this tomorrow, but I want you to try it out. And this is where the volume of our cones and pyramids start to come into play, and you guys will have a little bit of exercises for you to do that. Finally, see if you can answer this question. Example number 2 on page 14. Okay, that's where you kind of want to finish. If you want to go further, there are more problems to work on, but this is my expectation for you. That means you've got, okay, 1, 2, 3, 4. You can skip this one. We'll talk about it a little bit later. 5, not an X there, but 5, and 6 problems. If you want to go on to the 7th, you can do that too. The 8th and 9th are also pretty easy, but my expectation is for you to all finish 6 of these problems. I hope you have a great time. Miss Kep or Miss Riggs will be able to assist you and direct you in exactly what to do. Remember, you're starting at page 11. going to page 14 and doing each of the volume problems. I'm going to have a fun time watching my daughter sing and dance and do some zoo stuff. I think she's talking about orangutans where each one gets a little part. So that'll be a lot of fun. I'll talk to you guys later and see you tomorrow.